Swallowing or deglutition. Swallowing is a complicated mechanism principally because the pharynx observes respiration and swallowing. The pharynx is converted for only a few seconds at a time into the tract for propulsion of food. It is especially important that respiration not be compromised because of swallowing. Now coming to this main topic, what are the stages of swallowing, and explain each stage in brief. Now there are three stages of deglutition, that is stage, and that is 1 voluntary stage, 2 pharyngeal stage, 3 esophageal stage. What is the main in voluntary stage is here. In voluntary stage it initiates the swallowing process. What is main in pharyngeal stage? It is a involuntary and it constitutes passage of food through the pharynx into the esophagus. Now coming to the esophageal stage, which is another involuntary phase that transports food from the pharynx to the stomach. Now let's talk briefly about voluntary stage of swallowing. When the food is ready for swallowing, it is voluntarily squeezed or rolled posteriorly into the pharynx by pressure of the tongue upward and backward against the palate, as shown in figure 74.2. This is, you can see in the figure, the voluntary phase. What happens? The bolus of food or water is voluntarily squeezed or rolled posteriorly into the pharynx by the pressure of the tongue upward and backward against the palate, as shown, so that the bolus enters the pharynx. Once the food or bolus of food enters the pharynx, the swallowing becomes entirely or almost entirely automatic, and automatic means it cannot be stopped. Now let's talk about the pharyngeal stage of swallowing. As the bolus of food enters the posterior mouth and pharynx, it stimulates epithelial swallowing receptor areas all around the opening of the pharynx, especially on the tonsillar pillars, and impulses from these pass to the brainstem to initiate a series of automatic pharyngeal muscle contractions as follows. Right? Note this. What happening in the pharyngeal stage once the food enters the posterior mouth and pharynx, it stimulates the epithelial swallowing receptors all around the opening of the pharynx, especially on the tonsillar pillars, and so that the impulses from this pass to the brainstem and that is to the swallowing center. Then it initiates a series of automatic pharyngeal muscle contractions as follows. 1. What it does, the soft palate is pulled upwards to close the posterior nares to prevent efflux of food into the nasal cavity. This is what happens with the soft palate. 2. The palatopharyngeal folds on each side of the pharynx are pulled medially to form a sagittal slit through which the food must pass into the posterior pharynx. Because this stage lasts less than 1 second, which stage this pharyngeal stage lasts less than 1 second, any large object is usually impeded too much to pass into the esophagus, right? Now 3. What happens with the vocal cords? The vocal cords of the larynx are strongly approximated and the larynx is pulled upward and anteriorly by the neck muscles, and the epiglottis swings back over the opening of the larynx. These actions prevent passage of food into the nose and trachea. What actions you can see? Your soft palate is closing the external layer so that the food doesn't pass into the nose, and thus these palatopharyngeal folds are approximating medially and pushing the food into the posterior pharynx, not into the anterior pharynx. And also the vocal cords are coming together, that is approximating each other, and also the larynx is moving upward and anteriorly so that it is providing space for the it is allowing or creating food some space to enter directly into the posterior pharynx rather than into the anterior pharynx, so that the food does not enter into the your trachea, right? How much great mechanism this is there. Most essential is the tight approximation of the vocal cords. It is most essential, but the epiglottis helps to prevent food from ever getting as far as the vocal cords. Destruction of vocal cords or of the muscles that approximate them can cause strangulation. Important clinical note: the upward movement of the larynx also pulls up and enlarges the opening to the esophagus. At the same time, the upper 3 to 4 centimeters of the esophageal muscular wall, called the upper esophageal sphincter, also called pharyngoesophageal sphincter, relaxes. Thus, food moves easily and freely from the posterior pharynx into the upper esophagus. Between swallows, this sphincter remains strongly contracted, thereby preventing air from going into the esophagus during respiration. The upward movement of the larynx, you can see in this pharyngeal stage of deglutition, upward movement and anterior movement. The upward movement of the larynx also lifts the glottis out of the mainstream of the food flow. So the food mainly passes on each side of the epiglottis rather than over its surface. This adds still another protection against entry of food into the trachea. 5. Once the larynx is raised and the upper esophageal sphincter becomes relaxed, the entire muscular wall of the pharynx contracts, beginning in the superior part of the pharynx, then spreading downward over the middle and inferior pharyngeal areas, which propels the food by peristalsis into the esophagus. This is very important. Once the sphincters gets relaxed and the larynx is raised, what happens? Now there comes the propulsions from the upper pharynx, starting from the upper pharynx, moving towards the middle and inferior pharyngeal areas, so that the food is propelled towards the esophagus or into the esophagus. To summarize the mechanics of the pharyngeal stage of the swallowing, what happens? The trachea is closed. Why the trachea is closed and the esophagus is opened, and a fast peristaltic wave initiated by the nervous system of the pharynx forces the bolus of food into the upper esophagus. Therefore, the entire process is occurring in less than 2 seconds. This is the brief overview or summary of the pharyngeal stage of the swallowing. What happens? Trachea is closed by lifting up of the larynx upwards and the vocal cords getting approximated each other, and the epiglottis swings backward over the opening of the larynx, and the light and the esophagus is opened. That is because the upper esophageal sphincters or the pharyngoesophageal sphincter or the upper 3 to 4 centimeter of the esophageal muscular wall gets relaxed happening here, right? Nervous initiation of the pharyngeal stage of the swallowing. The most sensitive tactile areas of the posterior mouth and pharynx for initiating the pharyngeal stage of swallowing lie in a ring around the pharyngeal opening. That receptors are called epithelial swallowing receptors that lie in a ring around the pharyngeal opening, with the greatest sensitivity on the tonsillar pillars. Right? Tonsillar pillars. Impulses are transmitted from these areas through the sensory portions of the trigeminal and glossopharyngeal nerves into the medulla oblongata, either into or closely associated with tractus solitarius, which receives essentially all sensory impulses from the mouth. The successive stages of the swallowing process are then automatically, means without any stop, initiated in orderly sequence by neuronal areas of the reticular substance of the medulla and lower portions of the pons. The areas in the medulla and lower portions of the pons that control swallowing are collectively called the deglutition or swallowing center. Note: the areas in the medulla and lower pons that control swallowing are collectively called the swallowing center or deglutition center. Important point. The motor impulses from the swallowing center, that is the parts areas in the medulla and the lower parts that control the swallowing. The motor impulses from the swallowing center to the pharynx and upper esophagus that causes swallowing are transmitted successively by the fifth, that is trigeminal nerve, ninth glossopharyngeal nerve, and 10th, that is vagus nerve, and 12th, that is 12th cranial nerves, and even a few of the superior cervical nerves, right? In summary, the pharyngeal stage of the swallowing is principally a reflex act. It is almost always initiated by voluntary movement of food into the back of the mouth, which in turn excites involuntary pharyngeal sensory receptors to elicit the swallowing reflex. Effect of the pharyngeal stage of swallowing on respiration. Let's look at it. The entire pharyngeal stage of swallowing usually occurs in less than 6 seconds, thereby interrupting the respiration for only a fraction of a usual respiration cycle. The swallowing center specifically inhibits the respiration center of the medulla during this time. During what time? That is during the pharyngeal phase of swallowing, halting the respiration at any point in its cycle to allow swallowing to proceed. That even while a person is talking, swallowing interrupts respiration for such a short time that it is hardly noticeable. Now, esophageal stage of swallowing. The esophagus functions primarily to conduct food rapidly from the pharynx to the stomach, and its movements are organized specifically for this function. The esophagus normally exhibits two types of peristaltic movements, that is 1. Primary peristalsis, 2. Secondary peristalsis. Primary peristalsis is simply continuation of the peristaltic wave that begins in the pharynx during the pharyngeal stage of the swallowing and spreads into the esophagus during the pharyngeal stage of swallowing. This wave passes all the way from the pharynx to the stomach in the about 8 to 10 seconds. That means the peristaltic wave which is started in the pharynx will pass all the way along the pharynx, esophagus, and finally into the stomach in about 8 to 10 seconds, right? If the primary peristaltic wave fails to move into the stomach, all the food that has entered the esophagus the secondary peristaltic waves result from distension of the esophagus itself by the retained food. These waves continue until all the food has emptied into the stomach. The secondary peristaltic waves are initiated partially by intrinsic neural circuits in the meandric nervous system and partly by reflexes that begin in the pharynx and are then transmitted upward through vagal afferent fibers to the medulla and back again to the esophagus through the glossopharyngeal and vagal efferent nerve fibers. The musculature of the pharyngeal wall and upper third of the esophagus is striated muscle. Therefore, the peristaltic waves in these regions are controlled by skeletal nerve impulses from the glossopharyngeal and vagus nerves. In the lower two-thirds of the esophagus, the musculature is smooth muscle, but this portion of the esophagus is strongly controlled by the vagus nerves acting through connections with the esophageal meandric nervous system. Right? Meandric nervous system. Now, receptive relaxation of the stomach. When the esophageal peristaltic wave, that is mostly the secondary peristaltic wave, approaches towards the stomach, a wave of relaxation transmitted through meandric inhibitory neurons precedes the peristalsis. Furthermore, the entire stomach and to a lesser extent even the duodenum become relaxed as this wave reaches the lower end of the esophagus and thus are prepared ahead of time to receive the food propelled into the esophagus during the swallowing act. Now let's talk about function of the lower esophageal sphincter, that is gastroesophageal sphincter. At the lower end of the esophagus, extending upward about 3 centimeters above its junction with the stomach, is the broad lower esophageal sphincter. Already we said upper esophageal sphincter, how much thickness or length is 3 to 4 centimeter. Here lower esophageal sphincter also is about 3 centimeters in length, right? Is the broad, right? At the lower end of the esophagus, extending upward about 3 centimeters above its junction with the stomach, is the broad lower esophageal sphincter, also called gastroesophageal sphincter. This sphincter, comprising of circular muscle, as we already know, normally remains tonically constricted. Tonically constricted means it is constricted somewhat with some tension, with an intraluminal pressure of about 30 mm of Hg, in contrast to the mid portion of the esophagus, which normally remains relaxed. When a peristaltic swallowing wave passes down the esophagus, there is a receptive relaxation of the lower esophageal sphincter ahead of the peristaltic wave, which allows easy propulsion of the swallowed food into the stomach. Rarely, the sphincter does not relax satisfactorily, resulting in a condition called eclasia. That means the food doesn't go into the stomach and it will remain in the esophagus if there is, right? This is discussed in chapter 75. Okay. This tonic constriction of the lower esophageal sphincter helps to prevent significant reflux of the acidic stomach contents into the esophagus except under abnormal conditions. Additional prevention of the esophageal reflux by valve-like closure of the distal end of the esophagus. Let's discuss about this. Another factor that helps to prevent reflux is a valve-like mechanism of a short portion of the esophagus that extends significantly into the stomach. Increased intra-abdominal pressure caves the esophagus inward at this point. Thus, this valve-like closure of the lower esophagus helps to prevent high intra-abdominal pressure from forcing stomach contents backward into the esophagus. Otherwise, every time we walked, coughed, or breathed hard, we might expel stomach acid into the esophagus. That is, without the food from the stomach, preventing the food from the stomach into the esophagus is done by 1. Lower esophageal sphincter because of its tonic constriction, and 2. a valve-like closure of the distal end of the esophagus. This is about the 3 stages of the deglutition and its brief explanation, right? Thank you.